Now, I did not come up with this title, although, so I think Jamie, you did, I think. But on the other, and it sort of gives a mixed message that why fight weed resistance? You're not going to win. On the other hand, I'm a big Star Trek fan, and does anyone know the name of this drone here? Yeah, but first name? No. Hugh. Yeah. So that's my evil cousin. So, let's see. Okay. So Canada is number 3 in terms of the countries with the most cases of resistant weeds. So United States first, Australia, and then us. We have 65 cases, about equally distributed between west and east. And you can see since 1987 that we've had about 2 new cases a year. So it's been fairly consistent in that regard. If you look at Alberta, we have 23 what we call resistant biotypes. It's pretty similar amongst the 3 provinces. You see a lot for Ontario, but that's mainly back in the 70s and 80s with all the triazine resistance that they had in their corn and soybean system. We do surveys, a new round of surveys every 5 years or so. So we do Alberta, Saskatchewan, Manitoba. That's why it takes 3 years to do a round of surveys. About 1,000 fields for each round. So the real random surveys began in the early 2000s, and we're just finishing up Alberta this year in 2017. And based on, if you crunch the numbers, the annually cropped land with resistant weeds, I projected will be 38 million acres. So that's over half of the annually cropped land. And when we finished Saskatchewan and I have the Manitoba data, so that's going to be actually an underestimate. So it is increasing rapidly, not only in Manitoba, which was the hotbed of resistance, but now in Alberta as well. Now, in terms of the cost of resistance, when we do these surveys with Julia Leeson, my colleague at Ag Canada, there's a grower management questionnaire that accompanies these resistance surveys. And so we asked them, what is the additional cost of managing your resistant weeds on that surveyed field in terms of either increased herbicide cost or yield penalty or yield quality loss? And when you crunch the numbers, it works out to $12 an acre on average in Saskatchewan. Of course, when we get the Alberta questionnaire finished, we'll see how those numbers relate, but I suspect it'll be fairly similar. So that's the cost of resistance, additional cost for growers on average. Now, besides the field surveys, we have a prairie weed resistance testing system. It's a public lab based in Regina. There are other testing labs as well, so this isn't the only one, but these are the maps based on submissions either by producers or industry on behalf of producers for the 2012 to 2016 5-year period. So if you look at Group 1 resistance and focusing on Alberta, 195 cases. And that's fairly similar to what we found in the previous 5-year period from 2007 to 2011. So when we add up, since the first case of Group 1 resistance back in 1991, the number of cases now will be in the tens of thousands. Group 2 resistant wild oat, quite a bit less. And when we plot these maps, we basically go by the number of cases at a given location, so different colors. Only 50 cases over this 5-year period. And then what really starts to limit herbicide options for growers is Group 1 or Group 1 plus Group 2 resistant wild oat. In that 5-year period, 98 cases. Again, fairly similar to the previous 5 years. There were other submissions to this lab. Group 1 Persian Darnell, which is becoming quite common in the southern Alberta and also southern Saskatchewan, Swift Current area. Group 2 cleavers across the central and northern regions of the grain belt, Saskatchewan, Manitoba. Alberta, Saskatchewan. Smartweed is starting to appear, Group 2 smartweed. Group 2 green foxtail starting to appear more so in Saskatchewan than here, but we're starting to see it here as well. Hemp nettle, stinkweed. We're seeing a lot of cases of stinkweed now with Group 2 resistance in Alberta. And Group 9 kochia, we didn't get many samples submitted, but the glyphosate-resistant kochia in those two particular areas. So when we talk about multiple resistant wild oat, I've talked to a lot of growers, and I'll be at the Alberta Agronomy Update Conference in Red Deer in the new year. But it's very difficult talking to those producers because when you have a case like this where Group 1 and Group 2, really starts to limit options. And what the growers are doing now is asking me, okay, which Group 1 or which Group 2 still work? We're at that stage right now. Does clethodim, Group 1, still work? Does simplicity, Group 2, still work? So we're sort of at that stage now where, they're going to try whatever still works, and if they're lucky, there might be one or two herbicides that still work, depending on what the mechanism of resistance is. Because you can see in wheat and barley that if it is blanket Group 1 and Group 2 resistance, which I've seen before, you really start to limit options like left with Avedex or Fortress in terms of the post-emergence options. Not only cereals though, but in crops like field pea, if you have Group 1 or Group 2 resistant wild oat, you start to again limit your options. Cleavers is becoming, Group 2 cleavers is becoming very widespread, again in the central and northern grain belt, Alberta, Saskatchewan. So again, it starts to, of course, pulses are quite dependent on Group 2 chemistry, so I know researchers like Eric Johnson are always trying to find new herbicide modes of action to use for pulse growers to use. And in lentil, where there's Group 1 or Group 2 resistant wild oat, Group 2 resistant wild mustard is just rampant in central and southern Saskatchewan. It goes right down from, say, Rosetown to Swift Current. Every field has Group 2 resistant wild mustard. And Group 2 kochia, of course, which is becoming, which is all populations now are Group 2 resistant kochia. I haven't found one population yet in the prairies that is not Group 2 resistant. So. Our last glyphosate-resistant kochia survey was in 2012, so we surveyed 309 sites. So about 5% of those sites indicated by the red dots. They originally started in Warner County, but now it's found in a lot of counties, whether it's Tabor, Lethbridge, Vulcan, Cypress, 40 Mile, Acadia. And these are just submissions from 2012 from producers, and you can see that it goes right up from, say, Medicine Hat all the way up into south of Rosetown. So, and not shown here, also Acadia, and then the special areas 2 and 4 also has glyphosate-resistant kochia. And I'll talk about the new survey that we did this year for glyphosate-resistant kochia. You may have seen these slides before. It was surprising when I looked at the literature, there hadn't been any work done on how much seed is actually dropped when kochia tumbleweeds break loose and they roll across the landscape. So this study that Bob Blackshaw led in Lethbridge, we looked at distance of tumbleweed movement, and you can see that the percentage of seed dropped increased linearly. So after about a kilometer or 1,000 meters, 90% of the seed had been lost from that tumbleweed. And when you equate that with the number of seeds, it's about 100,000 seeds per plant. All of those are viable seeds, they're non-dormant, so that's why kochia is becoming such a big problem here in not only southern Alberta, but southern Saskatchewan. It was a fun project, though, because you could attach these GPS collars to the tumbleweeds, and that's what tracked their movement. At Scott, Saskatchewan, we looked at the speed of the tumbleweed, so it was quite variable wind speed that week, and so we had quite a range of wind speeds, and you can see at the top speed, which 300 centimeters per second, which is about 6 miles an hour, is a bit faster than I could walk, but we just let the tumbleweeds go, and they, again with the GPS collars, you can see that the faster they moved, the more seed they dropped, and again it was about 80 or 90%. So by the time they moved a relatively short distance, they would have lost most of their seed until they hit a fence or some other obstacle. Now, besides resistance carried in the tumbleweed by seed movement, kochia can also, the resistance trait can travel in the pollen when it's outcrossing. And the bad thing about kochia outcrossing is it lasts a whole month. Whether it's June, July, but it lasts a long time. And of course, the resistance can go from a resistant plant to a susceptible plant, and then that becomes resistant. So it's a double whammy. Pollen flow, if you have two plants close to each other, it's only about 5 or 7%, but that does vary a lot with distance because it's wind pollinated. So depending on the direction of the wind, you can get outcrossing rates up to 17 to 20%. So it's quite high. This was a study we did, confined field study we did in Saskatoon, where we had a central area of glyphosate kochia, and then we had different spokes in all directions, and that's how we measured outcrossing in that study. Recently, again with Bob Blackshaw's help, we looked at another key feature of kochia, and I was surprised that this hadn't been looked at in the literature before, is how long does seed persist in the soil? And so we had these cylinders, and we buried the kochia seed, either it was at the surface, about an inch deep buried, and then we buried it 10 centimeters or 4 inches. And you can see that, and we buried it in October 15th. And you can see by mid-April, there was about 80% viability left, so 80% good seed. By mid-May, that had dropped to 40%. And by mid-June, it was pretty well toast in terms of viability. And surprisingly, it didn't matter how deep that seed was buried. It all lost its viability, so it basically wouldn't be able to germinate after mid-June. And we found similar results at Scott as well. So we have time for 50% loss in viability, time for 90% loss. So that's actually to our advantage because kochia has such a short seed life in the seed bank. Some researchers have thought, well, what if we were to do some extreme tillage and actually just bury that seed so that it's buried and it doesn't come up again? Or if you can prevent seed input, that certainly would help you to drive down that seed bank almost to zero very quickly. One other interesting thing we found with glyphosate-resistant kochia, we used our thermal gradient plate in Saskatoon, and we actually looked at germination of populations from Saskatchewan, Colorado, and also Kansas. And when we crunched all the numbers, we found that glyphosate-resistant kochia emerges quite a bit slower than glyphosate-susceptible kochia. It's hard to see all the different graphs, but this was fairly consistent whether it was in Saskatchewan or Kansas. And it also had reduced germination compared to non-glyphosate-resistant kochia. So the question is, can we exploit this in terms of management? If it's germinating slower than normal kochia, can you, say, delay your burn-down treatment to catch that glyphosate kochia, which is coming up? You might be missing it in an early burn-down because it does come up later than non-glyphosate kochia. So, and we also found the same for first leaf when first leaf appeared. So, and this collaborates other studies. We found that glyphosate kochia has delayed emergence, delayed flowering, and so what this we attribute to is it's sort of what we call a fitness penalty because of the mechanism of resistance in this weed, which is it has 25 to 30 extra copies of glyphosate target site protein, and with all those extra copies, it's had sort of a effect of delaying emergence and and flowering. These are some experimental trials that Bob Blackshaw did. So these were conducted at Lethbridge and Colehurst from 2013 to 2015, looking at glyphosate-resistant or Group 2 resistant kochia in spring wheat. I've just highlighted the ones which are not Group 4 mode of action. So you can see most of that are Group 4 herbicides who are really dependent on Group 4 herbicides, whether it's dicamba, fluroxypyr, or others listed here. Fairly good control of GR kochia, Group 2 kochia, but what about Group 4 kochia? I don't think so. So when you look at field peas, again, studies from Bob, I've highlighted those that are post-treatments here in this slide. And again, a lot of these are fall treatments. Fairly poor control overall, whether it's glyphosate resistant or Group 2. And then you have, again, these are experimental. And then, so again, there's, it becomes a bit more of a challenge when you start to get multiple group resistance in this weed. And so, although I want to be clear, it hasn't yet been confirmed, although we are investigating triple resistant kochia. Having said that, I'm sure it's out there already. So if you look at if those growers that have to manage Group 2 plus Group 4 plus Group 9 kochia, whether it's wheat, barley, canola, flax, pea, or lentil, you can see that options start to get very limited. Now the question is, if it's Group 4 resistant, is it resistant to all the classes of Group 4? For example, dicamba is in a different class than fluroxypyr. So based on our limited data, it is cross-resistant, but that'll be a question to look at. And so the burn down or fall applied treatments will become increasingly important for triple-resistant kochia. And these are the registered treatments. So you can see that, for example, the Group 14s become important, and using the old Group 3s, Edge, Treflans. One thing that always surprises me is why we don't use paraquat more often in the burn down to relieve some of the selection pressure with glyphosate. For example, you look in Australia, they use as much paraquat as they do glyphosate for the burn down. So that's something that I think eventually is going to happen. Of course, you've heard the big news this year is that canola is now king in terms of acreage across the prairies. It now is 22.8, although I think in Alberta, wheat is still number 1. So I think, but this is prairie average. So that's been a big change in terms of how, besides being very profitable, when I talk to a lot of growers, they use canola to help manage all the Group 1 and the Group 2 resistance out there. And I was surprised when I did the survey in southern Alberta this year, last month, how much canola there was relative to the previous 5 years when I saw a lot of chem fallow 5 years ago. I didn't see that much this time around. I saw a lot more canola. So canola wheat is the most common rotation in Western Canada on average. And when I was surveying in the Peace Country, I saw a lot of canola. So they're definitely using a lot of canola. And if you look at the net returns, of course, this is from Sask Ag. You can see that in terms of net returns, canola is very attractive. But so is lentil and maybe less for the other crops. Recently, Neil Harker and I published our top 10 herbicide-resistant weed management practices. We published this because what we saw out of the Weed Science Society of America, they had their 12 recommended practices, but their 12 did not coincide with our 10. And also we prioritized them from number 10 to number 1. And this is based on research that we've done over the last 25 years. But more importantly, when we do the surveys, we can link the resistance results in the field to what the grower is doing in terms of management practices. And then we can identify best management practices. And for example, one thing that really comes out is those producers with greater crop diversity have less resistance. That comes out time and time again in our resistance correlation. Competitive crops, scouting, those that do more scouting, mixtures, of course, tank mixtures, herbicide group rotation, weed sanitation, etc. So this is something that we advocate in terms of growers trying to have a framework in terms of managing their resistance going forward. We don't have the Alberta grower questionnaire results in yet. This is from Saskatchewan in 2015, 600 respondents. So this was their top 10 weed management practices. What struck me was, so in terms of adoption, so the number one was scouting before in-crop treatment. I was surprised how much scouting had really increased dramatically since the last questionnaire. We have crop rotation, that's good to see, tank mixing herbicides, herbicide rotation. And then 11 to 20, we get into competitive crops, increased seeding rates, narrow row spacing, etc. So one thing though, as I mentioned, whether it's consultants, advisors, or the grower themselves, this indicates that they're doing a lot more scouting than what they used to. And one thing that was interesting in that questionnaire was that these four practices, crop rotation, herbicide group rotation, tank mixing herbicides, and the burn down, were more targeted for those that had resistance than those that did not. Those are the four that we found differences between growers with and without resistance. So what we found overall is those with dealing with resistance tended to scout more, tank mix herbicides more, rotate herbicides more, grow weed competitive crops more often, and increase crop seeding rates. So that was interesting, and it's sort of gratifying to know that some of them are listening to what Neil and I and Bob Blackshaw are saying all these many decades in terms of best practices. So we did the big Alberta survey this year with the help of Linda Hall at the University of Alberta, Neil Harker and his gang. And so we surveyed 250 fields. So we do these surveys just before harvest. So most of it was done in late August, early September. The last survey was in 2007, so it's been 10 years since we did the last survey. Very generous funding by Western Grains, Alberta Wheat Commission, Alberta Pulse Growers Commission, Alberta Canola Producers Commission. So we thank them for their strong support. So I was, and when I do the surveys, I do at least half of the fields just because I want to know what's out there, and it gives me an opportunity to talk to growers. So I was right at the US border, and that was very interesting because I saw a drone fly by, and I wasn't sure who it was from, but I sort of made sure I was on this side of the border. And then 3 weeks later, I was very up at the 60th parallel, so that's a lot of ground to cover. So, but again, it was a lot of fun, and I got a bit wet when I was up here, but otherwise it was okay. Now, besides that, it was a very busy year in Alberta. The last week in September, we also did a kochia Russian thistle post-harvest survey. We always have to do kochia and Russian thistle after harvest because the weeds are too green. The seeds are non-viable if we try and collect samples in, say, August, September. So these are the number of sites that we visited. We call this a roadside survey because it's random, but these were the number of sites per county or municipal district. So we did a total of 330 sites. And what we want to see, of course, is how fast glyphosate-resistant kochia is progressing from the 2012 survey. We included Russian thistle because glyphosate-resistant Russian thistle has been confirmed in Montana as well as Oregon. So we just wanted to see if this weed, if we were seeing any glyphosate resistance in Russian thistle. We did collect a number of samples, certainly not as many as kochia. But more importantly in this survey, we're going to screen it for group 4 resistance, dicamba, fluoroxypyr, just to determine what the extent of group 4 resistance in kochia. And also Russian thistle, we want to screen with group 2 because we don't have a good handle on how much group 2 resistant Russian thistle there is out there. So with these 2 surveys, I was out in the field quite a bit, but we'll have the results of this survey in by early spring of 2018. This survey probably by the end of 2018. It just takes a long time to put samples through the greenhouse. So with that, just to wrap up, so I'm a very strong believer in surveys and having producers test samples for resistance if they suspect resistance, because until you know, it's hard to decide how you're going to deal with the problem. So far, we only have kochia with glyphosate resistance in Western Canada, but we have to be prepared when other weeds develop resistance, whether it's cleavers or green foxtail or wild oat or what have you, perhaps Russian thistle, we'll see. And that's always, it's our number 1 herbicide, of course, and so that's always paramount. And for kochia, we really looked at, in terms of a research perspective, we've done everything. From the mechanism of resistance all the way to how to deal with the problem. So now, of course, we're moving towards group 4 resistance now because we're relying on these old chemistry, group 4, and of course some of these crops that are being introduced with stacked traits, whether it's glyphosate and dicamba or what have you, that'll increase the selection pressure. So far though, prairie-wide, of course, wild oat continues to be our number 1 problem. And you know, a number of growers in Alberta have run out of options already to control wild oat, except maybe Edge or Treflan, some of those products. So in terms of post options, they've already run out of options, and so this is serious. And then kochia, of course, I would say it could be our number 1 problem here in southern Alberta. Kochia is increasing in abundance, and a lot of that is due to resistance, but of course the spread. So we used to have, within the weed science community, we used to have a wild oat action committee, but I would also argue that we probably need a kochia action committee to try and focus resources even more on these 2 weeds. But I tell you know, the same tortoise and hare fable. Right now, there's no magic bullet in the works. There's no new herbicide mode of action in the pipeline, at least for the next decade, according to industry sources. So we have to use our existing tools, and so it's going to be tough slugging over the next few years. But we are looking at some new technology, whether it's the harvest weed seed control with the Harrington seed destructor that Neil Harker and Brianne Tiedemann at Lacombe are evaluating this year in Alberta, so this has been the first year. And so there's some things and some more molecular things that we're looking at, but we're going to have to deal with this for quite a while. So with that, I'd be happy to answer any questions. Thanks.